practice question. Okay. Yeah. So is my screen is visible?
Yes, sir.
Okay. So I will not go into the theoretical part. Like I will take the questions, and by questions only we can discuss the concept. Okay. So yeah. Right.
Sir, could you also take example of integration by in UV rule integration by limits?
Yes. I have actually example. I have added few examples. Yeah.
Okay.
Yeah. Okay. So this is the first question. Okay, so how many critical points are there in the curve? Okay, so we are given the domain -4 to 4 in the figure, and we have given the hint like f dash of c equals to 0. So what is critical point here first? Yes, anyone?
Here we
F
can
double dash is 0. Sir.
Yeah, so suppose if we are given the function f of x, right?
yes,
So
sir.
if you want to find out the critical points, what we do? We differentiate this f of x and equal to
Differentiated,
Equal to
calculated.
0.
yeah.
If that's equal to 0.
Yeah, then the root of this equation will be the critical points, right?
Yes, sir.
Yes, sir.
Yes.
Yeah. So when we differentiate this function, so can we call it, so at particular point, can I call it at a slope of that particular curve at that particular point?
Yes.
Yes, sir.
Yes,
Yeah.
we can call it.
Yeah. So if slope is equals to 0, it means that line is parallel
Parallel
to
to x-axis.
yeah.
Parallel to x-axis.
Yeah. So how many critical points are there?
2.
2, sir.
Yeah. So first one is this one. Second
Yeah.
one is this one, right?
Yes, sir.
Yeah.
So
So there are 2 critical points. Yeah. Okay. See the simple one. Any doubt in this question?
No, sir.
No, sir.
No, sir.
No, sir.
Okay, so next question. So we are given the function f of x. Okay, now we have to we are given some options we have to see. So at first we have to find out the number of critical points. So
we have to first differentiate it and then calculate the roots.
yeah. So if I differentiate the f of x, what will be the f dash of x here? Like 3.
3 into x square, only x square.
Yeah. So
And 2x and 1.
plus 1. Right. So that is x square minus 2x plus 1. That is x minus 1 ka whole square. So the roots are x equals to 1, 1, right?
Yes,
So
sir.
how many critical points are there?
1, sir.
1, because these two are
1, sir.
yeah, critical points should be distinct, right? So number of
Sir,
critical
x will
points
be
is
plus 1 and minus 1.
sorry.
X will be plus 1 and minus 1, right?
No, right? Here you can see the root of this equation will be 1, 1, right?
Yes,
X minus 1 ka whole square,
Minus
then
1
x equal to
square
1.
is there. Square is there. So square can take.
Yeah. So x
2
minus 1, I can write it as x minus 1, right? Equal to 0.
Hey.
So x equals to 1, 1, right? Yeah.
Okay. Then
So
it
the
will be
number
only
of-
1 critical.
Yeah. So the number of critical points is 1. Now the second derivative test is that x minus 1 is a local maximum for f of x. Okay. So if we take the second derivative of any function, say f of x, and if that particular
minus
function, yeah. So if that particular function any point is positive, then we can say that
Then it is the local minimum.
Minimum.
yeah, it will have local minimum at that point. And if f double dash of x at the second derivative at particular point is less than 0, then we can say that at that point it has
Local
maximum, right?
Yes, sir.
Sir, f double dash.
Yeah.
Yeah. So here the second derivative is local maximum. So if we differentiate this equation again, what we will get? F double dash of
2x minus 2.
2x minus 2.
And
So
2 common, say 2x minus 1.
yeah. So f double dash at 1, what will be the value? 0. Right?
0.
So this is the, yeah. It is a minimum or maximum. Yes, anyone?
We cannot solve, sir.
We cannot
Yeah.
say that, sir.
We
It is a
cannot
saddle
say.
point.
It is inflection point, right?
Yes.
Saddle point. Yeah.
Saddle point.
So neither minimum nor maximum. So this is not correct. Right. So second derivative is that x equals to the local minimum f. This is also not correct, right?
Yes, sir.
So observe that f double dash of 1 equals to 0. Okay. So the second derivative is inclusive here. Also observe that f dash of x.
Sir, sorry to interrupt.
Yes.
This second point, can you, the third point, can you please explain once more? The second derivative test, this one.
Yeah, second
It's
derivative test
equal to 1, not minus 1.
is equals to 1, right?
Yes, sir.
That's why I'm not able to answer. Ki x minus 1, how is local maximum? Okay.
Is equals to 1, right? Yeah.
Okay, okay.
You see
Now I
this-
got it.
Hmm.
Okay.
Yeah. So in the fourth option, if you observe that, okay, so second derivative test is inclusive here. So also observe that f dash of x does not change its small neighborhood of x. So in this case, it is always non-negative. Is this true?
Sir, is this
What does this
solved
question
with
mean?
session?
Hello. Yes. Solve
It
it.
is 0, sir, in x is equal to 1.
Yeah.
X is equal to 1 and it will be 0. But what does this question means actually? Means I am not able to understand what the
Yes,
question
sir.
means.
True. Not true. According to us.
True, sir. Because it's inconclusive. F
Yeah. We
double.
cannot say whether it is.
Conclusively, we cannot say about that anything.
Yeah.
Okay, okay, I got it. What does it mean? So if it is inclusive, we can't say anything about the sign of that
Sign of
function,
that.
right?
Yes. Right. Yes, Rohit. This is solve with us session. I have taken this question from the solve with us that practice assignment. Okay. Yeah. Okay. So this one is true or false? Yes, correct or wrong option?
It is true.
True, sir.
True. Okay. I think this is the
Does
same
not change.
option, right? Same is there, right?
Yeah, same.
Yeah. Okay.
Same.
Okay. Fine. Any doubt in this question?
No, sir.
Okay.
Sir, if both options are
Sir,
same, then
sir, could you
we pass,
please
sir?
explain me the second, third option, sir? Whether is that right?
Second and third option.
No, the third or fourth option, sir. Sorry. Observe that f of 1 is equal to 0.
Yeah. So we have observed that f double dash of 1 equals to 0. So second derivative test includes here. We cannot tell whether it is having a maximum or minimum at that point, right?
Correct, sir. Correct.
Yeah. So also observe that f dash of x does not change sign in a small neighborhood of 1. Right.
Mhm.
Yeah. So in this case, it is always a non-negative number. So this thing, right?
Okay. So
Yeah.
that can never be a non-negative number.
Yeah.
Okay. Okay.
Okay. So okay, can you tell me the
Sandeep?
first concept of global minimum, global maximum?
If the function at the
Sir,
From all critical points.
sir, on the second question, sir, previous question, sir, in
Okay.
total, sir, only one is correct. Second number is correct. Critical number of critical points is 1. None of the others, sir.
oh, there are multiple answers.
In the portal.
Yes, sir.
Okay. Okay. Let me see.
Except answer is the number of critical point is 1 only. In the portal, sir.
Sir, from where are these questions from? Are they from graded assignments?
Yeah. No. It is from solve with us question only. Like you can check the portal. Solve with us week 9. Not graded question.
I
Yeah.
thought it would be from pre-order. So that's all.
No. Okay. So okay, f of does not change its small neighborhood of just it is always non-negative. So this function will be always non-negative, right? We have given the domain. No. Right. Yeah, so here we are getting the two real roots, right? 1 and comma 1, right?
Yes, sir.
Yeah, so if we put like both the value, it will be always neighborhood of 1 will be not change the symbol. This one is correct, right?
Okay.
Because if we get -1 comma 1, then if we put the value say in this function,
Yes,
what
sir.
I will get. So
Sir,
here,
Sir, even in the derivatives, first derivative
huh?
is square minus 2x. That's all, no, sir. For constant, we have to add 0 only, no, sir. You added +1.
Where? Here. No.
Yes,
See,
sir.
derivative of this x cube will be 3x square, right? 1 by 3 is
Yeah.
constant. Minus
Ah,
x square
just
will be
minus
2x.
2x.
X is there, so derivative of
Plus
x
x.
is 1.
Okay, I thought it is 1, sir. Okay.
No, no,
okay, sir.
no, yeah. I will check this option, okay?
Yes, sir.
If I'm not wrong, the f dash of 1 is equal to 0, right, sir?
Sorry, yes, f dash of x equals to 0, then we get this equation.
Yeah, so f dash of 1, the fourth option, sir, f dash of 1, the answer is 0 if I'm not wrong, right?
Yes, it will be 0 because these are the roots of this equation only. No? It
Yeah.
will be 0. Yeah.
But in this case, it is always non-negative. So 0
Yeah.
can neither be positive or negative. Maybe in
Yeah,
that
yeah.
case.
If here you can say, right?
Yeah.
Yeah, yeah. So I think this is true. Okay, I will check with the team. Okay.
Sir, it is not showing.
Yeah, yeah. In the portal, it is showing only this second option, right?
Yes, sir.
Okay, okay. I will check with the team. Yeah. Okay. So tell me, what is global maximum or minimum, and what is local? What is the difference between local and global here? Just anyone?
Global is for all.
Local is
Global
for
is
a
only
specific.
Sorry,
specific
anyone?
under a small sub range. The small range local is there, and global is for entire one.
Global is for entire.
Function, and local is for a small subset of that portion. Means a small portion of that function where
Okay.
there are local maximum or minimum, and global is for entire function.
Okay, say suppose
Technical-
I say that there is global maximum. So can I say that it is local maximum also?
Yes.
Can happen. It can
Yes.
happen,
Sir.
but not. It is always not the case. It may happen that it.
Okay. So in this question, what we have to find out? Okay, let's see whether this first option is correct. X equal to this local maximum or not. So what we have to do? First, we have to find out the critical points, right?
Yes, sir.
So what is f dash of x for
First, we
this?
have to differentiate.
Yeah.
Minus
Minus 2x plus
plus
2. Now equate it to 0. What I will get? X equals to
1.
upon 2.
1.
Right? It equals to 1. Right. So when x equals to 1, so in order to check local maxima or minima, I have to take the second derivative of this function, right?
Yes.
So what is second derivative?
Yes.
Minus 2.
It
It will always be negative, right?
Yes.
always be negative.
Yeah. So we are having the
Local.
maxima
Local
or
maxima.
minima.
Minimum, sir. Local
Minimum.
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 What?
Negative is there,
Sir,
right?
yes, sir. Yes, sir.
Maxima, sir.
Yeah.
Yes, sir. Local
Maxima.
Yeah. So we are having the local maximum, right?
Yes, sir.
First
Maxima.
option is correct.
Yes.
Okay, let us check for second one.
X is equal to minus 50. We have to put minus 50 in that function.
Which one? Here or this one? First one or second one?
If it is
First
global, we were
one.
supposed to use
First
both, right,
one,
sir?
sir.
If it is global,
First one, sir.
Second one, minus 50.
global minimum, then we were
Second one,
supposed to
it
use
is
both.
minus 50 there. So
Yeah,
minus
just
50.
minus
Second
50,
one.
right? Second one.
Second one, sir.
So, okay. So at first we have to find out the critical point for this function, right?
Yes, sir.
So what are the
Yes.
critical? We have to differentiate that, right? So it will be
It's x squared.
3x squared.
3x square.
3x square.
And equate to 0. What are the roots?
0.
If I take the second derivative, what I will get? 6x, right?
6x.
So
6x.
yeah, so at this point it will equal to 0.
Yes.
So at this critical point, there is no at
Your
this
saddle point.
there is no maximum, there is minima, right?
Yes,
Neither
sir.
maximum nor minimum. So now I can check the end points, that is minus 50 and 0. Okay. So let us see at
Okay.
minus 50 what I am getting.
So can you please explain again? We have second
Yeah,
derivative.
it will be. Sorry.
6 into minus
Yeah.
50.
Yeah, 6x. Then how it comes 0, sir?
No, 6x is not equals to 0. If I put x equals to 0 in f double dash of x, that is f double dash of 0 equals to 0, right?
Yes.
Yeah, so
Yes,
that
sir.
is what I am saying. It is not.
This zero is comes from first derivative.
Yeah, so these are the critical points, right?
Yes.
Yeah.
Minus 50 you have to keep in f dash or f double dash.
Minus 3.
Yeah. No, we have to find out the global minimum, whether it is maximum or minimum, right?
We have to put that minus 50.
Yeah, so we'll get,
minus 300 if I put minus
yeah,
50.
it will be a large number, negative
In
number,
that
right?
function, we have to
Yeah, so I will get the,
50
It's true, sir.
125
yeah.
plus 3.
Sir,
It will be a
this
negative.
is the second portion.
Hmm.
Second option, minus 50 is a global minimum. Where do we have to put that minus 50 value to get the global minimum? F dash x
F
or
of
f
x.
x?
Yeah, f of x only. See,
Fx.
if I given the f of x and say we have the domain, say 3 and 6. Okay. So
Okay.
what I have to do first, I will differentiate it. I will find out the local point. It's critical points here. At that critical points, whether my function is having the local maximum or minima. Okay. So I will
Yes.
put that value in f of x. Then what I will do in order to find out the global minimum, I will also put this end point. It is 3 and 6 in the function. Then I can, okay, so which I will get the maximum or minimum point. Okay, so
Sir,
I
I
can,
To
have
find the global
a question
minima, we
regarding.
have to put the value in the fx function.
yeah, yeah.
Sir,
Yes.
F double
Sir, I
dash,
have a
Yes, Om Kumar, yeah.
sir, F double dash value is in negative. That means it's a global maximal.
No, we are not putting, in order to find out the global value, we are putting it in like f of x, not in f double dash of x, right?
F dash x में put करेंगे ना sir?
Sorry?
F dash
तो
x.
local के लिए. वो
No,
local
no.
के लिए.
For local, we'll put in f double dash of x and we'll check whether we are getting the positive or negative sign, right?
So for global,
For global, we can directly put the
For x.
values and see with the critical, at the critical point, what we have to compare with the critical points. Okay. But here,
Okay.
there is
Sir, if
no,
you don't mind, can you please explain the question once again, sir? Because I'm totally out of.
Yes, sir. The
logic.
second point, can you please?
Yeah, especially second point, sir.
okay. Is there any other question where we have to calculate only local and global?
Sir, one thing here in this for first option here is x equal to 2 by 2. How 2 by 2 comes? Can you explain it also? If we
Where?
differentiate the f
To
of
minus
x,
2 by minus 2, so that is equal to 1. Actually, minus 2x plus
2D.
2. So x is equal to minus 2 by
Okay.
minus 2.
Here you are talking about, right?
Yes. Sir.
So I can write this as, I can take this minus 2x on this side, right? So it will be 2 equals
Okay,
to
okay,
2x.
okay,
Yeah, so
okay, sir.
from
But
this, I can,
basically, okay,
yeah, yeah.
basically I thought
Simplification.
just put the 0 here.
No. But
Okay.
we have to equate this f dash of x equals to 0.
0. Okay,
Yeah.
got it.
So second point is not clear, sir. Can you please?
Yeah, so just wait 1 minute. Let me check any activity question.
Sir, I have a simple question. Means when we are calculating local, we are calculating a double derivative. When we are calculating at global, we are calculating at the function. Why it is so?
We have global points are calculating at the end point, right? These are the minus 50 and 0. These are the end point of this particular function, right? So my domain is from minus 50 to 0, right?
Yes.
Yeah.
Sir.
So we have to check. So in local, what we are finding out between this, is there any point or not, where we are getting the maximum minimum value?
And that can be tangent only.
Yeah.
So that's why we are calculating with means double derivative. I got it, sir.
Okay. What happened? Now, okay, just take this function, okay? We are only considering f of x as minus x square plus 2x plus 30,
Plus 3
and its domain is 0 to 50, right?
Yes, sir.
So now here we have to find out the global maxima or minima or local maxima or minima. Okay.
Okay.
Okay. So first we'll find out the critical points. Okay. So how to find out that f dash of x?
Derivative.
Yeah. So here you can see we already find out that is 2x
Yeah,
plus
yes, sir.
2.
Minus 2x
And
plus
if we
2.
equate to 0, we'll get x equals to 1, right?
1. Yes, sir.
Now take the second derivative of this function, that is f double dash of
Okay,
x.
it's -2.
Yeah, and then that is -2, and then that put the critical points at this particular function at f double dash of x. So what I will get f double dash of 1, it is -2 only, right?
Yes, sir.
Yeah.
Yes, sir.
So this is negative.
Yes, sir.
If my double dash of x at particular point say C is negative, then I can say at that point there is local maximum. Okay.
Yes, sir.
And at particular that point C, if you are getting the value positive, then
Positive, then it is local minimum.
minimum. Okay. First we have to calculate the second derivative. Then we have to put that critical points here. Okay. Now here we are getting a negative value at x equals to 1. So I can say at x equals to 1, local maxima is there, right?
Yes, sir.
Yes, sir.
So, okay, so if there is exists local maxima, can there exist local minima also at the same?
No, sir, it's only negative.
no,
sir.
sir.
It's only local maxima.
Okay. Okay, so here we are getting x equal to the local maxima. Now, in order to find out this global maxima or not, so if we put x equals to 1 in f of x, what I will get? F of 1. So this is a critical point, right? At this point, I am getting the local maxima. So what this mean? Like if I put x equal to 1 in my f of x, I will get the maximum value of this function. So what I will get here, -1 plus 2 plus 3.
6,
right?
sir.
That is,
Answer is
minus
4.
1 square, no, sir.
yeah,
Right.
that is 4.
6
Right?
square.
4.
No, minus x square is there, right?
No, it's minus.
Yeah.
Yeah, yeah.
Minus should be taken separately.
So
4.
f of 1, I am getting value 4. Okay,
Yeah.
so this is at critical point. This is as critical point, right? That is my local maxima. Now I have to find out the value of this function at 3 and 6 also. Let's say
So
f
once
of
again,
3.
sir.
Okay.
Sir, in f of 1, you wrote as -1, no, sir. It's minus x square. So minus will get cancelled out, no, sir.
No, minus is actually common, ma'am. It's not linked with the -1 or 0.
Here you
Understood.
can see function.
It is
minus
separate.
x square. Yeah.
Okay.
Yeah.
Okay, okay.
It is not like this.
Okay, okay, sir.
Yeah. It is minus x square. Yeah. That's why if I put x equals to 1, I will get that function value 4. Now, in order to check whether we are having the global maximum minima, just put the end point, that is boundary points in the equation, that is f of x. So f of x will be, f of 3 will be minus 9 plus, I'm putting x equal to 3. So 6 plus 3.
6 plus 3.
So that is equals to 0, right?
Yes, sir.
Yeah, so that is equals to 0. Okay. So now I have to put f of 6. I have to calculate f of 6. So what I will get, minus 36 plus 2 into 6, that is 12 plus 3. Oh, sorry. What
Yes,
I'm
sir.
doing? I'm taking this function. Sorry. I have calculated this. I have to consider 0 and 50, right? Sorry.
Yeah, that's right.
why
So 0 and
I
50.
was about to ask, sir, where did you
Sorry,
take
I'm looking
3
at
and 6?
here only. Yeah, sorry.
Okay,
So we
sir.
have to calculate f of 0, right? So what is
So
f
0
of
is
0
3.
here?
Answer will be 3.
F
Sir.
of 0 is 3.
3, yeah.
Now just
Yeah.
calculate f of 50 here.
50. Okay.
It is minus 2500.
2500.
Yeah, it will be like,
Plus 100.
yeah, plus,
103.
so it will
So
be
that will
negative
be
number,
2000
right?
negative value. Yeah.
Yeah. So which one is maximum? 4, 3, or this negative 4, right?
4.
4, sir.
Yeah. 4.
Yeah. So at this point, I have local maximum also, and I can say global maximum also.
Okay.
You can see at this point, I am getting the maximum value of that function 4, right?
Yes, sir.
Yeah.
So then we should consider that point as a global maximum point.
I'm confused.
But I'm sorry. Yeah. Go ahead.
Yes. I'm just checking. Yes.
So obviously minus 50 is coming as a global minimum only, right? So because the values come closely to 2300 change.
No. That is not a global minimum. We don't know the minimum value here. You can only talk about the maximum value, because f double dash of x at particular point is always negative, right?
Yeah.
Yeah. So we cannot decide whether having the local minimum or not.
No,
We are
I'm
not-
talking about the second option, sir. It's global minimum because the value is very less, like 2,300. Is that because of that, sir? F of 50, sir. F of minus 50.
Hmm.
We are getting an answer of minus 2,300 and change, right?
Yeah, this is a negative value.
Yeah, so it will be global minimum, right, sir? From that wrong.
No, we cannot say that.
Oh, okay.
Yeah,
So
we
how do we
cannot say
find
as
global
global
minimum?
minimum. No, for this function, because f double dash of is always negative,
Mhm.
there will be no local minimum point.
So by then, how come the answer x is equal to minus 50 is global minimum, sir?
For that, we are considering this equation, right? I'm talking about this particular f of x only, this one.
Okay.
I'm considering this only.
Okay.
Okay. So for this particular function, f of 1 at f of 1, I'm getting value 4. And at this boundary condition, I'm getting 3 and negative value. So maximum is at 0.1 only. So my x equals to 1 will be local maximum also and global maximum also. Okay.
Okay.
This one option will also be correct.
It is global maximum as well.
Yeah, global maximum also. Like if you see the solve with us on the portal, yeah, we are given some points in that. So global maximum over the entire function, right?
Local maximum or global maximum because the value is.
Yeah.
Sir, but if the value is positive, then we will consider that as a minimum, no, sir. So here 4 is positive value.
No, 4 is positive. It is a function. It is a value of
Okay.
this particular function at this point. Right?
Function.
Yeah.
Okay, sir.
So what it say, like we cannot get more than 4, the value of this function greater than 4 in this particular domain from 0 to 50.
Sir, sorry to interrupt. Please, can you explain that index function global maximum and global minima once? It's all got messed up in my head. I'm not able to get it.
Yeah, take this function only. Don't consider these two functions. Only consider this
Okay.
function only, f of x. Right? We have the domain from 0 to 50. Right? So in
Yeah.
order to find out the local maximum minima, we have to differentiate it. Right? We have to find out the critical point. So at first, what we'll do, we differentiate this f of x and equate it to 0. Right? In this way,
Yes.
we'll get the critical points. Right?
Yes.
Now we'll again differentiate. We take the second derivative of this particular function and see. We'll try to put this value in that particular function. If you are getting negative, then we can say at that point there is local maximum. If you are getting that value of this f double dash of at particular point c, that is f double dash of c is positive, then we can say it is local minimum. Okay.
And that means here is local maximum.
Yeah,
If
because
that's
this.
what
Yeah, see, here
minus.
there is no variable, right?
No,
It's
no
simply
variable.
-2. It will be always negative. So it will have maximum value only, right? So
Okay.
yeah, so say suppose I have one more root that is -1, and here I am adding. Okay, so I have one more at x equals to -1, and this is x. So if I put x equals to 1 here, it will be negative. If I put x equals to -1, it will be positive, right?
Positive, yes.
Yeah. So in that case, I can say at x equals to -1, this particular function will have the minimum. Minimum value, right? Local minimum. Because this function, this f double dash of -1 will become positive if there is -2x, right?
Yes, okay.
Yeah. So in that case, I can say it will be at that particular x equal to -1.
Sir, in f double dash, there is no -2x, sir. It's just -2.
Yeah, no, I'm just taking
an
an example. So suppose if I have x equal to -1 also, and we have said double dash of x -2x. So in that case, if I put x equals to 1, I will get negative value. If I put x equals to -1, I will get positive value.
Positive value.
So x equal to 1, there will be local maximum, and x equal to -1, there will be local minimum.
Okay.
Yeah. But in this case, only -2 is there, no variable is attached. So here we'll get the local maximum only, right?
Okay.
Sir, I'm not able to get this file.
Then the global maxima will be global maxima thing. Can you explain once in that case?
Yeah. Yes, Rohit, what you didn't understand?
I'm not able to get this file.
Better with some other examples, sir. Can
Yes.
global...
I'm looking at the example.
Sir, how we get global maximum?
Okay, is there any portion activity question where we have to find maximum, minimum, like global? Let me see. We have given the function, okay. Okay, yeah, here you understood, right? I am finding out where I will get f double dash of x something with the variable, and I will get two roots here. So that function I'm taking. Just one minute. Activity 1. Critical points. Yeah, okay. We'll discuss activity 9.2, question number 8. Not yet. This one, I'm sharing.
The activity number?
Activity 9.2, question number 7. Okay, so is my screen is visible?
No, sir.
This question number 7, AQ.
Yes, sir.
Yes, sir.
AQ 9.2. Okay, so we have given this particular function, and this is the domain, right? 0 to infinity. So say f of x is x by n and n upon x, right? So now in order to find out the critical points, what I have to differentiate this particular function, right? So what will differentiation of f of x here? Does anyone?
1 by
Differentiation
x
of this.
square upon
1
1
by
by
n
n.
Because 1 by n is a constant, right? I can take it
Minus-
outside, and derivative of
minus-
x is 1. So that is 1
So
by
n by
n
x square
x square
minus
upon
n
2
by x square.
minus n
9
by x
square.
right? Now in order
Yes,
to
sir.
find out the critical point, I have to equate this f dash of x equals to 0. Now if I equate this, what I will get? So x square equals to n square, right?
Yes, sir.
X equals to plus minus n. So these are my critical points. Okay. Now, in order to find out whether my function has local maximum or minima, what I have to do, I have to take the second derivative of this particular function, right?
Yes.
So this is my f dash of x. I have to differentiate this particular function again. So that is f double dash of x. What will be the value? This is constant, right? 1 by n. So it will be 0. Now minus n, what is the derivative of 1 by x square?
Minus 2x raised to minus 3.
Minus 2 by x.
Yeah. So minus 2 x to the power 3, right? So here I will get twice an x cube. Right?
Yes.
Now if I put this critical point here, say f double dash of, say first we'll put plus n, what I will get? 2n upon n cube, right? That is 2n square. That is positive value, right? This n is constant here, right? Hello.
Yes, sir.
Yes.
So, yes, sir.
So if I put f double dash of x minus n, so what I will get here? Instead of x cube, 2n minus n in cube.
minus
That
n
is
cube.
minus 2 by n square, right? So it will be negative value, right?
Yes, sir.
Yeah. So now just put x equals to n in this f of x. If you have to find, so at x equal to n, I will get the local minimum point, right?
X is equal to n.
If I put x equal to n in f double dash of x, I am getting the positive value, right?
Yes, sir.
Yes,
So
sir.
it means my function will have the minimum value at this particular point.
Local minima.
A local minimum, right?
Yes.
Last week and we have had in this week as well.
Sorry.
You are not audible.
Okay. Oh, okay. So here, so at x equals to n, I am getting my local minimum point, right? So what will the value of that particular f of x at x equals to n?
2.
N by n plus n by
2, sir.
n. So that is 2, right?
We have completed.
Right. So I am getting f of n equals to 2. Now put this boundary condition in at particular function. So what I will get f of 0 here. So f of n is 2.
So those are not included. So if we include that.
0 by n plus n by 0.
So it will be 0 plus
Infinity, sir.
infinity, right? It is not defined at particular point. Now just put
Yes.
f equal to infinity. Because these points are not included in the range, right?
No, sir. This is open interval.
Yeah, we cannot do. So I can say that at n x equals to n equal to x equal to n, this function is getting the maximum value, right?
No, sir.
Sorry,
Minimum.
minimum value, right?
No, sir. Minimum value.
That is local minimum also, right?
They just
Yes.
Yeah. And can I say that because at this boundary condition, this function is like if you put x equal to infinity also, I'm getting infinity, right? So this is not defined, right? So this function is not defined. So can I say that at x equals to n also it is global minimum? Because see, I'm not considering minus n. Why? Because can anyone tell me why I'm not considering this minus n?
Minus
Because
n,
the
then it will be
value
minus
is
2.
positive integer.
No,
We
no.
are taking only positive integers, sir.
Yeah, the range of the domain of this particular function is positive, right? 0 to infinity, right?
Yes.
It will be negative number. So that's why we are not considering this. So this function will only have the minimum point, that is x equals to n. Local and as well as global minimum.
Yes, sir. Okay, sir.
Yeah.
Sir, one question. Suppose f double dash value will be minus n. In that scenario,
F double dash value will be
here f double dash n value is a positive. That is the local minima. If it comes in a negative, but here domain, we are taking the domain in a positive sense, but f double dash value will be negative. In that scenario, can we consider the minus part or not?
no. Minus n is not in the domain of this particular function. Here you can see 0 to infinity. If it is from minus infinity to infinity, then we can consider that minus n point, and at this n, I am getting the local maximum. If I consider the domain of this particular function minus infinity to infinity, okay. But this point is not included in our domain, right? 0 to infinity.
Right.
That's why I'm not considering this point.
Okay.
Yeah. Okay, so in the last session, any example has taken on this? Global maximum minimum.
Yes, sir, I think sir was explained related to global minimum or maximum.
Sorry?
In last session, this thing is explained by the sir. Global maximum and minimum. Right.
Yeah, you can watch that. I think Vicky has explained in the on the Friday session also.
Yeah.
I'm not getting that example now. Here we'll get the 2 points. Like I will get the local maxima also, local minima also, global maxima and global minima. Like we can compare so that. Okay. No issue. Okay, so this part is been explained in the last session, right? Riemann sum. What happened?
I'm not clear with the previous question, sir.
So we are not done with the previous. Okay, okay. Yeah. So we have discussed that x equal to 1, there is local maximum also, there is global maximum also. Okay. Now
Can
let us,
happen.
yeah. Now let us see whether at x equals to minus 50 there is global minimum or not. Like simply you have to put that particular boundary point in the f of x.
Sir, I'm getting option D and F also correct, but it's not correct according to the solution, sir.
Option D is you are getting correct.
Option D and F.
Sir, the question you are discussing is from activity question only, right? This question from local maxima and minima.
This is
Same
question
is
from you can see the solve with us not graded assignment is there. I'm taking
also it
question
is the
from
question
there.
from activity 9.2.
Okay,
Same
question
question.
can be there. Yeah. For this question, you can see question number 3, solve with us.
Yeah,
Assignment.
appended.
Yeah.
Appended.
Sir, sixth option is correct, sir, in this.
Question.
Third question, this only. Hello.
1, 2, 3, 4, 5. See this one.
Yes, sir.
Okay, let's discuss one by one. Okay, so at x equals to 1, we have the local maxima, right? And global maxima also, right? So this one is clear to you, everyone, right? These two options. Hello?
Yes, sir.
Yeah, we have discussed this thing, right? Yeah.
Yes, sir.
Yeah. So now x equal to minus 50 is a global minimum or not? For that, we have to
Yes.
differentiate this particular function. So what I will get, f dash of x will be 3x square.
3x square.
I equate it to 0. So what are the critical
Yes, sir.
points?
0.
Yeah, this 0. So now take the second derivative of double dash of x. I will get 6x, right? So at this
Yes,
particular critical point, what is the value of the particular function?
0.
0 only, right? So at this particular point, x equals to 0, there is neither maxima nor minima. Okay. Now let us
Saddle
check.
point.
Yeah. Now let us check for the global maxima minima. Just put the boundary condition inside the f of x. So here I will get, say, minus. It's a big number, right? You can see.
Yes, sir.
250, not 2500. It will be 50 ka cube. So minus 50 cube.
12500.
Yeah, so it will be a big negative number. So I can say that is a global minimum. Okay.
Yes, sir.
Now x equals to 0, global maxima. No, because x equal to 1 is a global local as well as global maxima. So this is not correct.
Yes.
Now f of 0 equals to 3. Yes, I am getting f of 0 equals to 3.
0.
Yeah,
Yes.
here you can see f of 0 equals to 3. And f of 1 equals to 4. So 0 cannot be a global maxima.
Yes, sir.
Right?
Yes, sir.
So this one is correct, right?
On portal it is not correct.
Why not correct?
Yes, sir. In portal, it's not showing as correct, sir.
Okay, on portal, yeah, it is not so. Because here we can see x equal to the local maxima also, and we are find out at the boundary condition also, right? So we are getting f of 0 equals to 3, f of 1 equals to 4, and f of 50 is a negative number, right? So 0
Yes,
cannot be a global maxima. Huh? That is right, because 1 is maximum, right? So these two options are contradictory, you can see, right? X equal to global maximum also, and this one also. I think this one is
Yes,
correct
sir.
in the portal, yeah. This is correct. This is also correct. I think this option should be also correct, right?
Yes, sir. Yes.
Yeah. So this is not correct. X equal to 50 global minimum. No, we cannot say because we are not getting the particular function will be always negative, right? -2. So this is not correct. So f of minus 50 is greater than f of 50. So 50 cannot be a global minimum. We cannot
Yes, sir.
say directly because we have to find out the first critical point. We have to check the value of the function at those critical point, then compare with the boundary condition, boundary points, right? So this is also not correct. So I think this first, the second, this one, fourth, and last one is correct. So on the portal,
Yes, sir.
only 3 options are showing correct.
Sir, why sixth option is wrong, sir?
Now, from directly, can we say that if f of minus 50 is less than of f of 50, so 50 can be a global minimum? Is this a condition?
Yes, sir.
No, no. No, we have to find out the value of this particular function, the critical point also, na?
Yes, sir.
Yeah.
Sir, why option 4 is correct?
F of 0, we are getting the value 3, right? Here.
Yes.
And f of 1 equals to 4. So 0 cannot be a global maximum point, right?
Yes,
Global
sir.
maximum is x equals to 1 only.
Yes, sir.
Yeah, here you can say x equal to the global maximum. Yeah.
Okay.
Sir, f of minus 50 is about 12,497 and f of 50 is minus 2,397. Then option may be correct.
No, even if this is true, but we cannot say directly it is a global minimum. For that, we need to find out the critical point. We have to check the function, the value of the function at those critical point also. Then we have to compare, right? Directly, we cannot say if by this function only, we're looking at this condition only. This is not correct. Okay, so now next part, that is Riemann sum. So I think in the last session was totally on this concept only. So I will quickly explain what is this. Like, just remember, whenever we come across Riemann sum, just note this point, right? That is sum equals to summation of I, that is from 1 to n, f of xi star into this del of xi. Okay, say for example,
what is xi star? It is some interval.
Which one?
Xi star and delta xi. Means I always confuse.
I will discuss this one. So this is say f of x, okay, and this is my a and this is my b. Okay, so we are interval a b, right? Now I have to find out the area from a to b for this f of x. Yeah, under this curve from a to b, right?
From an interval.
This area, right? From a to b under this curve.
Different rectangles. We split it into different rectangles of same width.
What we will do, we can split it into different rectangles, right? Like this, and then sum it, right? We find out the area of each rectangle and then we'll sum it, right? So area of rectangle this plus this plus this plus this. So approximately we'll get the area under this curve.
Will be a very it will be a tedious process.
Yeah.
So we are only calculating rectangle.
Yeah. So I will only consider this point. Okay. So this say A1 and this say okay. So let's say this is maybe xi minus 1 and this is xi. Okay. So this is instead of x and y, just consider 0, 1, 2 only. It will be better. So I am dividing it into 1, 2, 3, 4, 5. So this is x0, x1, x2, x3, x4. Okay, consider like this. I will consider x1 and x2 only here. Okay. So, so this is my x1 and this is my x2, right? I'm taking this part only. Yeah, I'm taking this part here only. That is x1 and x2. So what is my delta xi here? So my delta xi is xi minus 1. It's I minus 1.
Yes.
So here my I is 2, right? So delta
x2 minus x1.
Yeah, so delta will be x2 minus x1. Say this is h. Okay. Now if I want to find out this area of this rectangle, how I will do that? I have to length multiplied by breadth, right? So I can have h multiplied by the height.
Yes.
Yes.
Yeah, so this is the width of this particular rectangle h. That is delta x here, right? So what
delta x is the width.
Sorry. Delta x
is the width.
Yeah, delta x is the width of this particular rectangle. Okay.
Okay.
Now we want this length also. So what is the how will we find out this length? I can simply put this point in f of x, right? Say f of x1. So I will get this value of y, corresponding value of y, right?
Yes.
Yeah. So if I multiply this f of x1 into this delta x, I will get the area of this rectangle.
Okay, so we are calculating the area of rectangle in terms of function and its height, and we are giving it different in. Got it, sir.
Yeah. So I am
But
calculating.
there was some concept, sir.
Yes,
There
yes.
was one concept of like over limit and undervalued and overvalued. Sir explained, means I was not able to understand what it was.
Over
There
or
was
under?
one,
Left or right?
yeah, that for xi star, that is left hand, right hand,
Okay.
means
Mid
average
term.
over.
Yeah. Okay. So up till now you understood, right? So here,
Yes.
this delta xi is the width of this rectangle. This f of xi will be the length of my rectangle. If I consider this, so this will
Okay.
be L and this will be delta x. So if I do the product, I will get the area of this particular rectangle, right? Now I have to
Yes, sir.
calculate the area of each rectangle, then I have to sum it in order to get the area of this particular curve, right? So same
Yes.
I am doing. So the summation of I equals to 1 to n. So what I am doing, I am just adding this 1, 2, 3, 4 rectangle here, right? So I will do f of x1 into del of x1 plus f of x2 into del of x2, right? Plus till f of x4 into del of x4. So this is the summation, right? So if we put I equals to 1
Yes.
here, so 1, yeah. So I am taking the sum of each and every rectangle which comes under this curve. So in this way, I will get the area of this curve under this particular, in that particular interval, right? So till now you understood, right? This is the length f of x.
Sir, is it mandatory that delta xi should be of equal width?
No, it is not mandatory. It can be varying also. It will be given in the question, yeah. See, so up till now, this is the length and this is the width, right? And we are getting the area of the rectangle here. But did you observe here? So if this is my curve and this is x1 and x2. So I'm considering this as x1 only, right? If I put xi equals to 1, but I can consider this x2 also for my length, right? I can find out the
Yes.
value at this particular point also. I can take this also.
Yes.
Right. So my left hand value will be xi, not xi. And you can see xi star belongs to xi minus 1 and xi. So here I is 2. So my xi star will belongs to x2 comma x1, right? So it can take any value. So this is, suppose this is 1 and this is 2. It can take 1.1, 1.2, 1.9. It can take any value, right?
Yes.
Yeah. So this my xi star belong to this particular x2 comma x1, right? So now what is left hand? What is that? Yeah, left hand side, like you have to consider xi minus 1, right? For left hand side. So instead of f x dash of I will consider it as f of xi minus 1. That
It is
is
basically how many intervals we are taking, right? Xi star is how many intervals we are taking.
No, xi star is basically at this particular point we are finding out the value of this particular function, right?
Okay, xi star is height.
Yeah, so there is one from left hand, right hand, and the average one, right? So when I say about the left hand, we have to take xi equals to this xi minus 1.
Xi minus 1.
Yeah, so here it is xi minus 1, that is value of this is 1 and this is 2. So right, this is 1 and this is 2, right?
Okay.
Yeah, so I will take I will calculate the function value at f of 1. On right hand, I will calculate the value at x equals to I, at xi, that is f of 2 here.
F of 2.
And here average I will do f of xi plus x of I minus 1 upon 2, right? So that is, in this case,
1 plus 2,
1
f
plus
of
2,
1.
right? Yeah. Are you getting what I am trying to say? Because I can consider any length here. I want to calculate the area of this rectangle, I can take this length also, this length also, this length also, and this length also, right? I can take any length, but the width is my fixed. My widths are fixed. That is this minus this, right? My width is fixed. I can take any length here, and I have to calculate the value of that particular function at this point, right? At this point. So that's what, yeah. If the question is it mentioned left hand, so we can consider it as x I minus 1. For right side, you can consider xi. For average, we can consider xi plus xi minus 1 by 2. Okay.
Okay.
We'll discuss our example. So this is how we calculate the area of a like any curve in a particular interval. Okay, under the particular interval, right? So if I take this limit, okay, now what is this n tends to infinity here? Yes, anyone? So I am dividing this in
infinite rectangles are there.
Yeah. So I am dividing this f of x in 4, right? So that's why my width is say h. But if this tends to infinity, so my width will become 0, right?
0.
It will tends to become 0.
It will contribute to negligible, and it will be same to the curve.
Curve only, yeah. So that's why we are getting the whole limit.
Yeah. So that was what was illustrated in the lecture also.
Yeah. So this is.
But at the last there were two also. One is the rectangle was over that curve, and one was where rectangle is under the curve, under curve and over curve. There was one concept for that. Is it mandatory or it is something other?
No, it is the same thing like what I explained. If you take this right hand side, that the rectangle will be over the curve, right? Like,
okay,
I think sir has taken this type of curve, right? So this is x1, this is x2. If I consider this x1, I will get this area, right? And if I consider this x2, I will get this area, right?
Yes.
Yeah.
So and now he was increasing the number of rectangles so that the function becomes very.
Because this is applicable for only this curve, right? What if my curve is like this? Say this like this, and I am considering this point, right? So it can be, we can consider any point from this particular x domain, right? Between these two interval, x1, x2, right? We can consider, we will get the approximate answer. We will not get the exact value in this case.
Exact.
Yeah, we will not get the exact area. We'll get the approximate area.
Because function is constantly changing.
Yeah, function is constantly changing. Yeah. So when the n tends to infinity, if we increase the number of rectangles, right, the width will get decreased, right? So my norm of p. So what is my norm of p here? That is norm of p will be maximum of delta xi. Okay. So this is my curve. I am dividing it only 3. So this width is 2, this width is 3, and this width is 5. So the maximum of this width will be 5. So the norm of this particular curve, from x0 to x3 will be 5. Okay, it is the maximum width of this any of the rectangle, right? That is 5. Now this maximum will tends to infinity. If this is tending to infinity, means automatically all the h value which is lesser than 5, it will also tends to infinity. It tends to 0, right? Sorry, it will tends to 0, not infinity. If my n tends into infinity, then
delta x tends to 0.
Also tends to 0. Yeah. So if my maximum delta xi is tending to 0, I can say that all the minimum value will also tends to 0. If my 5 is tending to 0, automatically 3 and 2 will tends to 0, right? Hello?
Yes, sir.
Yeah. So say this is 5 by n also. If I increasing the value, so automatically it will tends to 0, right? Same for 3 by n also, 2 by n also. If I only check for this condition, I can say automatically this will tends to 0 only, right? So that's why I'm taking maximum of xi. That is norm of p, that is tending to 0. Okay. So just remember one thing here, like all those things. Important points are this one. The sum of the Riemann sum is denoted by this one, summation of I to n f of xi del of xi. Now, if this limit n tends to infinity, I will get integral of a to b f of x dx. Okay. So it will be same. Let us discuss the example. Area. Yeah. Okay. First we'll discuss question 6, then we'll discuss the other question. This is visible, right? Question number 6.
Yes, sir.
Yes, sir. This one.
Yeah. So here f of x is given as equals to x. Okay. It is for the same question. So f of x is equals to x, and my xi is given I5 of n. This is my xi, and this is my interval 0 to 5. Okay. So interval is 0 to 5, and xi is I5 by n. Right?
Yes, sir.
Okay. So now we have to calculate the area under this curve. Okay. So at first we'll simply calculate this integral. So that is 0 to 5. What is f of x? That is x here, right?
Yes.
X dx. So what will be the value? X square by 2 equals to, if I put 0 and 5 here, that will be 25 by 2, right?
Yes, sir.
Yes,
Yeah.
sir. 25 by 2.
The value of this particular function, that f of x equals to x, from 0 to 5 interval, the area will be 25 by 2. So the value will be 25 by 2, right? So let us note this down. Okay. Now we'll solve this question by Riemann sum. Okay. So our answer should be 25 by 2, right? Yeah. So now what is Riemann sum here? Yes, anyone? I varies from 1 to n, then f of xi star into del of xi, right? And limits.
Sir, here xi, we will take the right hand, left hand, or middle point. Which one?
I will consider. Okay. We are given this function, na? We are given the condition already. So f of dx equals
Right
to
hand.
limit n tends
Right
to
hand.
infinity. Okay, wait. This is my definition of Riemann sum, right? I am getting the area under this curve, integral a to b f of x dx equals to limit n tends to infinity. This one, right? So you already calculate this value, integral value, right? This value you already calculate, that is 25 by 2, right? Now we can prove on right hand side whether we are getting 25 by 2 or not. So first calculate this. That is f of xi. Now what is xi star here? It is given in the question only. That is xi only. Yeah. Now what is xi? This one. I5 by n. Yeah. So what I will do, summation I n f of xi into del of xi. So what is del of xi here? This is a common question. Here you can see del of xi
5 by
means
n.
what? Yeah. So that is
5 by n.
xi minus 1. So I can consider this as x1 and this is x0. So x1 is 5 by n. If I put I equals to 1, I will get 5 by n. If I put I equals to 0, I will get 0. That is 5 by n. Right?
Yes.
You can consider any point. Say x2 minus, sorry, x3 minus x2 also. That x3 will be 3 5 by n and it will be 2 5 by n. So I will get 5 by n only. So my delta xi is 5 by n here, right? So my delta xi is 5 by n. Now put this value in this. What is my f of x? Sorry, f of x equal to x only, right? Hello?
Yes, sir. Yes.
Yeah.
Yes.
So if I put this xi into this, what I will get? So it will be summation of I equals to n to m. Xi is, what is xi here? I5 by n. So I into
I5 by
n into del of
5 by
xi
n.
into 5 by n. So it will be summation of I equals to 1 to n, 25
upon n square.
I upon n
25
square.
I by
N square.
Yes.
Right. This 25 upon n square is common. Sorry, not common, it is constant, right? So I can take outside. That is 25 upon n square, summation of I equals to 1 n I. So here we are given the formula hint, right? Use formula 1 plus 2 plus 3. So that is what is here, summation of x equals to 1 n n here x, right? It will be n. Lot of noise is coming. Okay, so it will be n plus 1 by 2. Same condition we can apply here. So what I will get? 25 upon n square. So I can write instead of this n plus 1 by 2, right? Because we're adding this particular integral, not integral, this variable I. Okay, so I is varying from 1 to n. So actually what is like this? This is basically this only, right? So I equals to 1, so I'm adding 1. I equals to 2, add 2. I equals to 3 plus 3 plus and I equals to n, right? So my this is equals to n plus 1 by 2.
Oh.
Just mute yourself. Yeah. Okay. You got this, right? This hint. So I can write this. I can put I equals to 1, right? Then summation plus I equals to 2, then sum, then I equals to 3 plus until I equals to n, right? So this is the meaning of this. Now it is equals to n into n plus 1 by 2, right?
Yes.
This one. So instead of this, I can write n into n plus 1 by 2. So what I will get? So here I will get 25 upon n square into n plus 1 by 2. So this n and this n will get cancelled, right? N square. So I will get
25 into n plus 1 by 2.
Yeah. So n plus 1 by 2, right?
Yes, sir.
So this is the value of this particular thing only. But I have to calculate the limit also, right? Now what I will do? I will simply take the limit. So that is limit n tends to infinity 25 by 2 n plus n upon n. I can write it like this, right? Here. Yeah. So 25 by 2 is constant. I can take it outside. 25 by 2. Okay. Noise is coming. Okay. So I can take 25
Yes,
by 2
then the
outside.
value is same, 25 by 2.
Yeah. So here I will divide this, right? N by n plus 1 by n. So it is 1 only, right?
Yes, sir.
So limit n tends to infinity 1 plus n by n. Now I can simply put n equals to infinity here, right? So I will get 0.
Yes,
so I will
sir.
get one answer. So I will get 25 into 2, 1, right? So that is
12.5.
25 by 2. Yeah. It is the same area we are getting, right? If we calculate it by, yeah. Okay. Any doubt in this question?
No.
So sometimes I get confused about fxi star. Fxi star, we just have to put the xi value.
Yeah, xi value only. Here because f of x is x now in this question. So suppose we have 3x plus 2. So in that case, we have to put this function in the place of xi. It is 3xi plus 2. That will be 3I into 5 by n plus 2. Okay. Then you calculate.
Okay. Just put this value in place of x.
X, yeah. In the question, it is mentioned at xi star equals to xi. That's why.
Okay.
Yeah. So it's the same question. Okay. This is question number 5. Okay. Any doubt in the previous question?
No, sir.
I was not able to understand.
Okay. What is your doubt?
The initial part, not the last part. Initial part where you started everything. So I was not able to understand at that point.
Which one? Like, can you tell me? Yeah.
How you started calculating this integration f of x dx, and then you move to that formula of summation this 25 by n square summation I is equal to 1 to n.
No, see, we have given this thing, right?
Yes,
First,
sir.
I am calculating delta xi. That is my xi minus 1, xi minus 1, right? Now, then from this I will get delta xi. Now simply I have to put the f of xi value. Now what is f of xi star here? That is xi only. Now what is xi? Yeah, that is xi this one. Yeah.
Given as I into 5.
Yeah, so this is my function. Okay, so let us discuss one more example. Same function is there. Here you can see f of x is equals to x, interval is there, and xi is xi minus 1. So what is our delta xi here? 5 by n, right?
5 by n.
Yes, sir.
Yeah.
5 by n.
So delta xi is 5 by 1.
Xi
This one is
minus
correct.
xi minus 1, right?
Yeah, this one xi minus 1. So this one is correct.
Yes.
The norm of p is 1
Yes.
by n here.
No, sir. Here the delta x is same. So
Yeah,
Norm of p is p5.
uniformly
yeah,
it
it is
increasing.
interval is same 5 by n, right?
Interval
Yes.
is same.
So norm will be 5 by n only, right?
Yes, 5 by n only.
This is not correct. Now in the previous question we have calculated if xi star equals to xi only, right? Now in this question we have to calculate xi star equals to xi minus 1. So what will get the value? Okay. So okay, so those who didn't understand the previous question, please note here. We have to find out the value of this only, right? Now take
Yes.
the summation of I is equal to n to m. What is f of xi star here? That is xi minus 1.
Yes.
Right. So
That
if I,
means I into 5 by n minus 1.
yeah, so
Yes.
my xi is I5 minus n, right? So what is
Yes.
xi minus 1 will be I
I
minus
into
1
5 minus 1
5 by
Oh,
n,
to
right?
5 by n.
okay.
Sorry, 2 5, how 2 5? I minus 1 5 by n only, na?
Okay, okay.
5 minus 5 by n.
Yeah. If you are just multiplying in this inside the bracket, right?
Yes.
Okay.
We are changing I to I minus 1. That is the thing. Right.
Yeah.
So it will be 5 minus 5 by n.
Yeah. So here I am getting x of xi minus 1. Now what is the formula? We have to put this xi star in the f of x, right?
In f of x, right?
Yeah. So what will be the here only x is there, so I can directly put I minus 1 in into 5 by n, right?
Yes.
F of x I minus 1 will be I minus 1 5 by n, right?
Yes.
Yes, sir.
Yeah. So this is my this value, and what is delta xi here? 5n.
5 by n.
Yeah. So
5
just
by n.
multiply. That is 25 by n square again.
25 I minus 25.
N square. Now
25 by
this
n
one
square.
is I minus 1, right?
Minus 1.
Summation of I equals to 1 to n. Now I can take
25 by n
25 by
square
n
is
square outside.
common.
Yeah.
Yes.
Constant. Summation of I equals to 1 to n. So that is I minus 1, right?
Yes.
Now what I will do, I can transfer the summation to I and 1 also individually, right? Summation of I equals to 1 and I minus summation of I equals to 1 and 1, right? Hello?
So we will just distribute it.
Sorry?
We will distribute this
Yeah.
summation
For
for I
summation.
and 1. Okay.
I and 1, right. Now what is this summation of I equals to 1 to n I? In the previous example we have discussed this, right? This one, right?
Okay.
So I can write 20
n into n minus
n square into n minus 1 by 2
n minus 1
minus. Now what is this value? Yes, anyone? What will be this value?
N.
How 1?
N, sir. N.
Summation of I equals to 1 n, that is 1, right? So what is the value?
N,
That is
sir.
N.
N. 1 n times addition. So
Yeah, it will be
1
n.
plus 1 plus 1 plus up to n, right?
Yeah, instead of 1, if it is there, say any constant number c. So if you are adding the I to value n, so it will be nc, right?
NC. Yes, sir.
Yeah, so here it will be
and
n
c is
into
just
1.
1. So
Yeah. So up till now everyone gets it, right? Everyone got the why I'm writing this.
I got it.
Yeah. Instead of 5, it is instead of 1, it is 5, then I can simply write 5 in here, right? So summation of constant
Okay.
will be nc. Because what does it indicate?
N times
That 1 plus 1 plus 1 plus 1 plus 1. So it will be n times of 1, right? Yeah, n
Yes.
times of 1. That this is what summation is. I'm summing 1 n times. That is n times of 1. That is n times of any particular number. So now I simply have to solve this. Now solve this bracket. What I will get?
So it will.
Sir,
We can take.
is it to be n into n plus 1 or n minus 1?
Which one?
This the summation of I is n into n plus 1 or n minus 1?
N minus 1, no?
Okay, n
N
minus
plus
1.
1. Oh, n plus 1, no?
I'm confused. N plus 1.
N plus 1 will be there. Yeah, n plus 1 will be there. Summation of n square. Can you tell me? What is summation of n square?
N into n plus 1 plus 1 plus 2n by 6.
Sorry? N into n plus 1?
Plus 2n plus 1 into 2n plus 1 by 6, I think.
2n plus
2n
Yeah,
plus
2n
1
plus 1 by 6. Yeah,
I think
this is
so.
for n square.
Yes.
Yeah. Okay. So here we are dealing with n and constant only. If it is n, you can simply mention n into n plus 1 by 2. If there is constant, you can simply n times of constant. Yes.
Sir, in the above formula, it's n minus 1 by 2 now, because we are taking n minus 1 terms only. Not n terms. The formula for n terms n plus 1 by 2. But if we put n minus 1 instead of n, the formula will become n minus 1 by 2.
No. Okay. I am using this for I have used this for this particular thing, right?
No, just you change the formula in this hint.
Yeah, because I have followed this, right?
Okay.
Yeah. Yeah, I got your point. What you are trying to say. See, if we 2 can multiply on this side, right? What I will get? 25 n square. It will be n
plus
n square plus n minus 2n by 2, right?
Yes.
Yeah. So what I will get?
N common, then n will cut 25 by n.
25 n square. That n square minus n will be there, right? Now
the n is common over there, so 1l will cut down.
Yeah. So I'm writing one more step here. That is minus n by 2, right? Now I'm taking n outside. Yeah. So
now take out n outside. So n square will cancel.
Yeah. So it will be 25 by n minus 1, right?
Yes, sir.
2 will be there, right?
Yes, sir.
So it will be 25 by 2 and n minus 1. So I think this is the correct one, right? Yeah.
Yes, 25 by 2 and 25 by 2 and n minus 1.
Yeah, 25 by 2 and n minus 1.
N minus 1.
Yeah. Any doubt now? Okay. So someone was saying, okay. Yeah. Okay. What happened? Okay. So what I have explained, everyone understood, right?
Yes.
What I have done here. Okay. So now in the previous question, if you observe, we have given this hint that 1 varies from 1 to n, then n into n plus 1 by 2, right? Now here we are getting hint that 1 from 1 minus n. We are not getting adding the n value, right? We are simply adding n minus 1 term, right? So that's why n into n minus 1 by 2, right?
Yes, sir.
Yeah. So here instead of this step only, like what happened? Yeah. So instead of separating this this summation, I can write it as here simply n into n minus 1 by 2, because we are adding till n minus 1 only here.
Yes.
That's why this hint is given to you, right? So whatever I have explained, summation of I wants to n c, it will be nc. This is not given to you, right? So both the things are correct, right? I have to simply expand this summation inside the bracket. Okay. So what the hint are given to you, we are adding till n minus 1. And same thing we are doing here, I minus 1 only, right?
N minus.
So yeah, it will be n into n minus 1. Now if you simply put n will get cancelled, you will get 25 by 2 and n minus 1. Same answer you will get.
Yeah. In the place of n, we have to put n minus 1. Then we will get the formula.
Yeah, you will get the same answer, right?
Oh.
Option 2, please explain the correct answer is.
Correct answer is this one.
Option 2. Option 2.
This is correct answer?
No, sir. No, sir. What is the
not
correct? Ny is not correct, sir. The px is what correct?
5n. Sorry.
Okay,
So why
sir.
this option is not correct? You are asking.
Yes, sir. Yes, sir.
Yeah. So actually, norm of p will be maximum of delta xi, right?
Yes, sir.
So delta xi is same here. It's common interval, that is 5 by n. So maximum of 5 by n, like all the 5 by n only, right? So this is not correct. So everyone got it, like why I have taken this, why I have done this, and why we are given this hint, right? We are adding this n term till n minus 1. That's we are doing, adding n into n minus 1 by 2 here, right? If you know this summation, you can also remember, like in exam, you can use this, like if hint is not given, that is summation of I and say any constant will be nc, okay? In the exam, hint will be given to you, or otherwise this type of hint will be given. So you can directly use this formula also, or whatever I have done here. I have stated the summation. You can do that also. Okay.
Yes, sir.
Yeah. Any doubt in this question? In Riemann sum?
No, sir.
No, sir.
So now we'll move on to definite integral part. This one is easy, right? Simply integration is there. Okay, so here we have given the function f of x equals to x square. Find the area under the curve represented by f of x which lie above the x-axis in the interval -1 to 2. So what simply we have to do? We have to find out the integral -1 to 2 f of x dx, right? So what is the integral -1 to 2 x square? It will be x cubed by 3. That is -1 to 2. So it will be 8 by 3 minus
plus 1
minus
to 3.
of minus 1 by 3.
It will be 3, sir.
Yeah.
Minus
3
of
square
minus
unit.
1 by 3. That is 9 by 3, that is 3. So
Yes,
3
3
square
square
unit will be
unit.
the answer. Yeah. Now similarly in this question we have to do the integration. The interval is 1 to e to the power 4, and we have to find out the value of a. Okay, so that area will be equal to 20. So what we will do? 1 e to the power 4 divided by x dx, right? So now this is equals to 20, right? So what is the integral of 1 by x? Anyone?
A by log x.
A is constant. I can take outside. So integral of 1 by x will be
Log x.
x. Yeah.
A log x is equal to 20.
And a to the power 4. So it will be a log e to the power 4. This is log e, okay, natural log.
Log base e.
Yeah. Minus log of 1. So log of 1 will be 0. 4 will come this side. So log e to the base e will be 1. That is 4a. Right? Hello?
Yes, sir. Yes, sir.
Yeah. Now this 4a is
Yes,
equals
sir.
to 20, right? We have given the area is equals to 20. Now this 4a equals to 20. So the value of a will be 5. Right?
Yes.
This will be 5. Any doubt in this part? It is simple integration.
Yes,
Sir, above question, 8 by 3 minus of minus 1 by 3, how it comes?
Yeah, okay. So suppose we are calculating the integral of any function, okay? So it is integral of f of x a to b is set f, okay? F of x is capital F, right? Now this is a to b. It will be, we have to put the value, that is f of b upper limit minus f of lower limit. It is f of a.
Yes.
Right. So I'm same I'm doing here, like I'm putting 2 here, that is 2 cube.
Okay,
It is 8 by 3. And this is minus, and minus 1 ka cube is minus 1 only, right? So that is 3. So that's why I written minus plus 9 by 3.
Okay. Thank you, sir.
Sir, how log x is converted to log ex?
Sorry?
Here is
How?
to 4.
Here.
Log e goes to 4.
No.
Base e.
Integration of 1 by x is log to the base e x. Okay.
Yes, sir.
So I am simply putting this upper limit ex instead of x here. Right?
Yes.
E to the power 4 minus log of 1. It's same f of b minus f of a. Same thing, right? Now
Yes,
4
sir.
will come outside by power property, right? Now log e to the base a is 1. So it is
Yes, sir.
4. Yeah. So log 1 is
4.
0. Yeah. It is 4 equals to 20. Right? That is a equals to 5.
Yes.
Right? Any doubt in this one?
No, sir.
Yeah, simple one. So now this one is important thing. Okay, how to solve this question, anyone? If you observe this limit integral, it is like this, minus a to a, right?
Yeah.
Yeah.
Okay, then minus a to 0 and 0 to a, right?
Yeah. So
This is 0 on.
minus a to a, right?
Minus 1 to
Yeah. So say suppose there is
-1
any function. Yeah. Listen to me. Suppose there is any function minus a to a and f of x dx. So this type of integral we have to calculate, which integral values from minus a to positive a. So if f of x is even, then that integral will become twice of integral of 0 to a f of x, right, dx. Now if f of x is odd, it will simply become 0. The value of this whole integral will become 0. Okay, so if my f of x is even, the integral will be twice of 0 to a f of x dx. If f of x is odd, it will be simply 0. Okay, now just check whether this particular f of x is even function or odd function. How to check?
Minus equal to
Yeah. So if I replace x by minus x in f of x, if I am getting minus f of x, then it is an odd function.
Yes, sir.
If I am getting f of x, then it is an even function, right? Now I can put x by minus x here. So this is an odd power, right? 2021. So it will be negative. So my this term will become negative, right? Cos of minus x will be positive x only, right? So cos of minus x will be cos x only, right?
Yes, sir.
Yes, sir.
Yeah. And sine of minus x will be
Minus sin x.
minus sin x. Okay. So this f of x, sorry, f of minus x will become minus x to the power 2021 cos of 2021 x minus of sine of 2021 x, right? Now I can take minus sign common, right? What I will get? Yeah, 21 into cos of 2021 x minus sine, sorry, plus of sine of 2021 x. So this is basically my f of x only, right?
Yes, sir.
So I am getting minus f of x. So this is an odd function, right? Now the integral, the value of this integral will be 0. Only if the
Yes,
limit
sir.
is carried from minus a to a. Okay, both the limits should be same. Okay. You can try the, if you want to prove this, you can simply consider any odd or even function, say minus a to a. You can consider this as first as minus a to 0 plus 0 to
a.
Yeah. So if it is an odd function, it will simply cancel out each other. If it is an even function, it will become the same, and you can add it, like it will become twice of integral 0 to a. Right. So you can try out, but remember this property. If the integral is varies from minus a to a should be same, like minus a to a, and if f of x is even function, then we have to evaluate twice of 0 to a f of x dx. If f of x is an odd function, it will be simply 0. So in this case, our f of x is an odd function. The value of this whole integral will be 0. And how to check whether my function is even or odd? Just simply replace x by minus x. And if you are getting minus x, that is odd function. If you are getting x, sorry, f of x, that is even function. Okay. Any doubt in this problem? Anyone?
No, sir.
Yeah.
No, sir.
Because we can use
Got
this
it.
property in complex integral also. Okay. Yeah. I think this is the activity question. Okay, we have to find out the area. How to find out the area? A is the area which is enclosed by f1 of x and f2 of x. Okay, we have to find out the 3. So yeah, so this will be f1 of x and this will be my f2 of x, right? So we have to find out the area enclosed by the curve. So this area we have to find out, right? How to find out? Yes, anyone? Geometrically tell me what we have to do if I want to find out the area.
Area and the rest. Integral from 1 to 1, 0 minus 1 to 1.
Yeah, see, First, I have to find out the intersection point of these two curves, right?
Yes, sir.
Yeah. So what I will do, I will first find out the area under this curve, this one, whole curve, right?
Yes.
Yeah. Now, if I want to find out the area of this particular thing, I have to subtract this area, right?
Yes.
Yeah. So I will find out the area of this particular F2 minus area of this particular F1. Okay. So between which interval? So for that, we have to find out the points. That is intersection point. So how to find out the intersection point? Okay. Say
To do equal that the both
yeah.
equation. 3x square is equal to 4 minus x square.
3x square equals to 4
minus x square.
So
That will give the
4x
intersection
square
point.
equals to 4. That is x square equals to 1, right? X equals to plus minus 1. So when x equals to 1, y equals to 3, right?
Yes, sir.
When x equals to minus 1, y equals to
Minus 3.
no, still 3, no?
Yes,
minus
sir.
1 plus square 3 only, no?
3, sir.
Yeah. So this is 1 comma 3, and this is minus
1 comma 3.
Yeah. So we have to find out the area of this curve from minus 1 to 1, right? Now, if you remember, we have just discussed one property, right? If we are minus a to a, we can use those property here. Okay, everyone got how I find the intersection point here?
Then this is
Yes,
the
yes.
positive. Fx is a positive,
-1 to 0, 0
even
to
a function.
Yeah. So I have to find out the enclosed area, this one. So area under this curve, that's area of f of 1 x minus area of f2 of x, right?
Yes.
That I have to do.
Yes,
So
sir.
first I have to find out area of f of x1. That is integral minus 1 to 1 f of x1, right? f1 of x dx. So what is f1 here? Minus 1 to 1 3x square
3x square.
dx. So whether this x square is an odd function or even function?
Even function.
Yeah, if I replace x by minus x, I will get a f of x only, right?
F of x only. Yes.
So I
Sir.
can write it as 2 into 0 to 1 3x square dx, right?
Yes, sir.
Yes, sir.
Yeah. So now just evaluate the integral, that is 3 into x cubed by 3 0 to 1. So if I put 1, 3 get constant, it will be 2, right? 2 is the answer, right?
Yes, sir.
Yeah.
So, sir,
3x
Yes.
square, 2
Yes.
square.
So this question is not in the solve with the
Yeah, this question is an activity
non-graded.
question. Activity question. Because
so
I have explained this concept, so that's why I want to take this question here.
So which question is
It's
this?
activity
Which
9.5, I think. 9.5, 9 question. So all the questions from Solve with Us is covered here. Yes, yes.
yeah, how did we change that limit for that even function? I think it's some basics that I'm missing.
No. In the previous example we have discussed here, right? It was here, like when we discussed this example.
Yeah, probably missed that too.
Yeah. So suppose we have minus a to a f of x dx. Okay, this type of integral is there, right? If f of x is even function, then my integral will be twice of 0 to a f of x. Okay. And if f of x is odd function, then simple, the value of this integral will be 0. That's it. So in the previous case, it is an odd function, that's why equate to 0. Now here, my function is x square, right? That is an even function. So I am writing it as twice of 0 to 1 3x square dx. So I will getting 2. So the area of this f of x1 is 2, right? Now I have to calculate the area under this curve f2 of x. So how to calculate? So I will erase this part. Okay, so area of f of f1 of x is 2. Now what is area of f2 of x? It will be integral minus 1 to 1, this equation, right? f2 of x, that is 4 minus x square. Now again check whether it is an even function or odd function.
Even
function, right?
Yeah.
Because if you replace x by minus 6, we'll get the same function. So I can write it as twice of 0 to 1, 4 minus x square.
Okay.
So it will be twice of 4x minus x cubed by 3, 0 to 1. So it will be twice of 4 minus 1 by 3, right?
Yes.
So 4 3s are 12 minus 1, 11. So 11 into 2, that is 22 by 3, right? Hello?
Yeah.
So I am getting this area. So this area I am getting, this whole area, that is 22 by 3. Now I have to subtract this particular area. This area I have to subtract, right? This area. So 22 by 3 minus 2. So 22 by 3 minus 2. So what I will get? 3, 6, 16 by 3, right?
Yes.
This is area enclosed by this 2 curve. Now we have to find out the value of 3a. So just multiply it by 3. What I will get? 16. Right? So the answer of this question is 16. That is 3a. Area is 16 by 3. Hello? Any doubt in this question?
No, sir. Got it.
Okay. Okay, this one is simpler. Just what is the area of x square or integral of x square? X cubed by 3, right? Just put 3 and 5, 3 and 2, you will get the answer here. I think 19.3. Okay. Yeah. So we have to here calculate the integral of 1 to 2, 3x square plus 1 by x dx. Okay. So what is the integral here? Yes, anyone?
3x cubed by
3 by 3x cube plus 1 plus log x.
Log x, right? That is 1.
ln x actually.
Yeah, log to the base 2. If I put x equals to 2, 3 will get cancelled. So 8, right?
Yes, sir.
8 plus log of
log x
minus 1, right?
Yes.
1 minus log of 1 is 0.
0.
So 8 minus 1, that is 7. 7 plus log 2.
Log 2.
Yeah. This one is the answer, right? So this is from the definite integral. Okay. Okay. So now main part is substitution. Okay. So integration by substitution. So whenever you come across this type of integral, like if you observe this composite function f into g of x, and that derivative of that g of x is given to you, that is g dash of x, then you can use this particular substitution function. Sorry, I'm not audible.
You are, yeah.
Yes, sir, you are audible.
Okay, okay. So if you come across this type of integral, yes, Ajit Singh, you want to say something? Okay. So when you come across this type
can
of
you please
integral,
describe that formula once more, because
So this type of integral is f of g of x, and that is g dash of x. Okay, so if you consider this example, so here you can consider that f of x will be sine of x, right? And g of x will be x square plus 1. Yeah, so this is f of g of x will be what? Sorry, what is the form of this particular? Like sine of
x.
Yeah, it's sine of gx, right? Sine of gx means what? Sine of x square plus 1.
Yes.
Right. And here what is 2x here? It is a derivative of this g dash of x. Right? G dash of x is 2x, right?
Yes, sir.
So this is g dash of x. This is my g of x, and sine of x is f of x, right? This is my f of x. Yeah. So now if I want to substitution, I can simply substitute g of x equals to u. Someone is talking. Okay. So what I will do, I can put the substitution like this, that is x square plus 1 equals to u. I can differentiate from both the side. What I will get? 2x dx equals to du, right? Hello?
Yes, sir. Yes.
Yeah. So I can put like 2x dx equals to du and x square plus 1 equals to u inside this. So what I will get? Sine of u into du, right? Hello?
He is trying to
Yes, sir. Yes,
understand.
sir.
Yeah. So what is the integral of sine? Like this, minus of cos u, right? Now, but now what is u here? X square plus 1.
Yes.
So I have to resubstitute it, that is cos of x square plus 1. So this is the answer of this. So you have to observe the integral first, whether I am getting any derivative here or not of this particular g of x, right? And you can use the substitution. Let us take one more complex example. Okay, here can anyone tell me like for which function I have to substitute here?
Sir, for the first example, what if it had limits, upper and lower limits?
Yeah, simply you can put the value here, right? This is A, this is B.
Can you explain that once more, please?
Sorry. Now, if there is a limit, then you can simply put the limit here, A and B, right?
Yeah, sir, I know for the single, but for the I am asking for UV rule.
UV rule. If you substitute it, right? For UV rule means okay, integration by parts, right?
Yes, yes.
No, here, if there's a definite integral, I can put it like when my x tends to 0. If you want to find out the value, you can simply do like this, or say suppose this A and B, right? So if when x equals to A, so my u will be A square plus 1, right? You can put here A square plus 1, and here it will be B square plus 1. You can put, right? Then there is no need to resubstitute. You can simply get the value. This is terms of definite integral. We are getting the value here, right? Here we are not finding out any value. I will take
So
one
how did you
example.
change those limits? Could you tell me that again?
We are substituting this x square plus 1 equals to u, right? So what is A, B tells here, like when x equals to A, what will be the value of this particular function, right? I can simply put x equals to A here. So my
Okay, you
lower
are
limit will
replacing
be
the
A square
limits
plus
in
1.
the substitution part. Okay.
Yeah. Here also upper limit will be B square plus 1, right? Simply x equals to B here. Okay, let us take this example. Okay, here what substitution I have to use? Substitution I have to use. By
Root
noticing this, can anyone?
Root x is equal to u.
Okay, if we use root x equals to u, then
Then half of
okay,
half of 1 by 2 root x is equal to
dx equals to
dx equal
du, right?
du. Yes.
So what I will get, tan to the power 4 u into x square u, right? Now
Yes.
so I don't have 2 here, right? So I can
No.
multiply and divide by 2 here.
Yes.
Yeah, so I can write it as du, twice of this particular function,
2.
right? Now how we solve this equation? 2 into
Bypass.
integral of how?
Oh, no, I don't know. X square x.
Here, just observe this. You can apply the same rule, substitution rule here also.
Let t equal to tan x.
Yeah. So let t equals to tan x now. Tan u equals to.
Why not we taking it in starting 10 root x equal to u?
Yes, that we can also do. Like if you take tan u equals to t, here will be x square u du will be equals to dt, right? So instead of this, you can put dt, and here you will get t to the power 4, right? Dt.
Yes, therefore t.
Yeah. Okay, so this is when we have to we have to substitute 2 times here. First, root x equals to u, and then tan u equals to t, right?
Okay.
So what if I use tan root x equals to u, because I am getting the derivative x square root x already, right?
Yes.
So I am putting tan root x equals to u. So derivative will be x square root x. Now the derivative of this root x, right?
Yes.
Yeah. So derivative of this root x will be
Half 1 by 2 root x.
That is dx equals to du, right?
Okay.
Now x square
That
x
will
2
be
root
in
x.
one time we can do this.
Yeah. So instead of this, I can put du, right?
Yes, sir.
So what I will get? 2 times of
U.
Okay, u here, right? U to the power 4 du, right?
Yes, sir.
Yeah, same thing we are getting here also, right?
Yes.
Yeah. So you have to observe like which substitute I have to make. Okay. So if I put tan root x equals to u, whether I have the x square root x derivatives there or not, that we have to see. Okay. So by practice, you have to practice more, then you will be able to understand which substitution we have to use, right? So this is one question from solve with us only, these two questions. So here directly hint is given to you. Substitute 3x equals to u and get dx equals to 1 by 3 du, right? Simply 3x dx, right? So 3x equals to u will be u and dx equals to 1 by 3 du. So that will be e to the power u 1 by 3 du, right? So I will get eu 3 plus c, right? Constant of integration. So u is 3x. I can resubstitute it e to the power 3x upon 3 plus c. Okay. This is not this one, right? Okay, it is
Yes,
clear to
everything is
everyone,
given
right?
here.
Hint is given, right? Yeah. So what if hint is not given to you? You have to observe what is the integral given to us, okay? Whether the derivative is present or not. Okay. Now same case here also. For the first term, substitute 2x equals to u. Okay, so integral is given to us. E 2x plus 2 to the power 3x plus 1 by 2x dx, right? So now I can write like this 2x dx plus integral of 2 to the power 3x dx plus integral of 1 by 2x dx, right? So in the hint, it is mentioned for first term, use 2x equals to u. For second term, use 3x equals to v. And for third term, use 2x equals to w. Okay. Hello.
Yes, sir.
Okay.
Got it.
Okay. You can try out this example. Okay. Easy one. You just have to substitute the value.
Yes.
Yeah. Now about the integration of parts.
Can you please up these things so I can take the screenshot of the question?
The question is there. You can see solve with us. Question number 10.
Okay.
Yeah. Solve with us. Question number. Question number 10. Right. Okay. Now about the integration by parts. So here, suppose we have two functions, f of x and g of x. Now if I want to find out the integral, okay. So what I will do, I will consider this one as first function, this one as second function. So keep the first function as it is, integrate the second function with respect to dx, then minus integral of differentiate the first function into integral of second function. Okay.
So we take also gs in the first term also.
Gx in the
first function, sir. We also take na, sir.
First function you can consider. For this, we have considered the f of x as a first function. Okay. So how to consider, which one to consider, we will discuss now. Okay. Okay. So just take the first function, keep it as it, and integrate the second function minus integral, differentiate the first function into integral of the second function. Okay. Then we have to solve this integral again. Okay. So I will discuss simple. Okay. So tell me, what is the integration of log x? Yes, anyone?
1 by x, sir.
Integration of log x, not derivative. What is integration of log x? Direct
Sir, we have to take 1 into log x and apply that.
X log x minus x.
Yeah, so x log x minus x, right? So how we
Yes.
came to know about this? Right? We have to solve
Formula,
this
sir.
integral. Not direct formula is not there. By integration of parts only we came to this. Okay. Okay. So log of x here. So only one function is there. Which one is second function? Does anyone? Now just
So we take log x into 1.
Log
right?
x is
into
u
one.
and
This one
log
right?
x u.
Yes, sir.
Yeah. So in
Log x u
mathematics,
and 1 v.
yeah. So in mathematics, जहाँ कुछ नहीं वहाँ 1 है, ठीक है?
Yes.
So I can write 1 as x to the power 0 also, right?
Yes, sir.
Yeah. So now just take this as a first function. No. Which one I have to take the first function?
Log
Here?
x, sir.
Log
Because
x,
the
right?
second preference is log x. First was is inverse, second was is log, third one is algebraic, then the trigonometric, and last one is exponential.
Yeah, this is ILATE. I stand for inverse trigonometric function.
For contacting
Yeah. L stand for logarithmic function. A stand for algebraic function, polynomial. T stand for trigonometric, and E stand for exponential, right? So here we have logarithmic function and algebraic function, right? Which one is first? Logarithmic, right?
Logarithm.
So we have to consider this as a first function. This one is as a second function.
Excuse me.
Yes.
Yeah, so this ILATE, where exactly do we use? Only for integration?
Integration by parts only.
Okay.
Yeah, because we have to consider first and second function, right? So we have to keep the first function as it is, integrate the second function, minus integral of derivative of this first function, then integral of second function, right? And again, we have to evaluate. So which one to consider first function and which one to second? For that, we use this ILATE. Okay. So here we have two functions, that is logarithmic is also present and algebraic also present, right? So one means basically x to the power 0 only, right?
Yes.
Yeah. So logarithmic will come first. So log will consider as a first function. So now simply apply this rule. Keep the log first function at it is, that is log x. Integrate the second function. My second function is 1, right? So integral of 1 is
x.
Yeah, integral of 1 dx. Minus in integral, take the derivative of the first function, that is log x. The derivative of log x is 1. Right?
1 by x.
Into integral of second function, that is 1 dx. Okay, so I will solve it now. So log x, integral of 1 is x, minus integral 1 into x upon x, right? So this x will get cancelled. So integral of 1 is, so log of x into x minus x, right? So this is x log of x minus x. Got it? Integral of log x is x log x minus x. Okay?
Sir,
Yes.
so by any chance, if we don't follow this ILATE, answer will be wrong?
Yeah, it will be a long procedure. Like if you consider this as second function, then again you don't know the integral of log x, right?
Okay. So it's just for convenience.
Yeah, just follow this rule, ILATE, in this way. If this inverse and inverse trigonometric function log x is present, just consider inverse trigonometric function as a first function. Okay. I will take one example of e to the power x sin x. Okay, because this is trigonometric and exponential also. Okay, it will not end because if you take the derivative of ex, it will be ex. If you take the derivative of sin x, it will be cos x. Again, take the derivative, again it will be the same sin x cos x. Right? I will take this function. I will take this. Okay, at the end. Okay, any doubt in this problem? Integration of log x. Why I consider I have one and then apply this integration.
Got it.
Okay. So now let us solve this question. So we have two functions here, right?
Sir, 1 minute. I want to ask something. Just like you did this thing, then 1 by root over x square minus x square is equal to sine inverse x by x. This is also done by that way.
1 plus x square. It will be sine
x square minus x square. This is also 1 plus x square. Yeah, sine inverse x.
Yeah.
So this is also done by this way, by parts. Or this is the formula we have to remember.
No, no, this is a standard formula, sin inverse of x, right?
Okay.
Yeah. So if you want to find out this, maybe you can put the substitution, but at the end you will get this. Like if you put x equals to, okay, so I want to remove this root somehow. How to remove this? How I
1
can
plus
remove?
s square equal to u square.
No, I want to remove this particular root x, root, right? So I
Root, yes.
take particular whole function as a square, right? Then
Square.
only I can remove. So I have 1 plus tan square x equals to sec square x, right?
Yes.
So I can put x equals to tan x. It will be sec square x. Okay. That will be,
Okay.
and then just instead of sec x, if you put 1 upon cos x, instead of tan x, you put sin x upon cos x. And substitute this, substitute, you will get sin inverse x. Okay.
Okay.
Yes, sir.
Got it.
You can try out. So this is the first function, this one is the second function. Okay. So now which one to choose the first function and which one is the second here?
And log x will be the first function and x cube is the second function.
Yeah, just ILATE, log will come first, right? Then algebraic.
Yes, sir.
You consider this as first and this one as second.
Yes.
Then same rule, like take the first function as it is, integrate the second function, that is x cube, minus integral of derivative of log x, that is first function, that is x, and integral of x cube, that is dx. So here, ln of x, that will be x to the power 4 by 4, minus integral of 1 by x, x to the power 4 by 4. So is x and this will get cancelled to the x cube, right? Dx. So what I will get, ln of x, x to the power 4 by 4 minus x to the power 4 upon 4 into 4, that is 16, right?
Yes, 4 into 4, 16.
Yeah. So yeah. So this one, so I can take x to the power 4 by 4 common, right? So what I will get, log of x minus
1. 1 by 4.
1 by 4.
1 by 4.
So the option it is not given. We have done some mistake, right?
Sir, you have integrated the line ln x.
Differentiate ln of x.
Twice.
Sorry, which step?
Maybe here on this. ln x minus 2.
X to the power 4.
Above that.
No, we have taken the derivative of first function 1 by x, then integral of second function x cube. So 1 by x into integral of second function x4 by 4. X just will get cancelled. That's x cube by 4. The integral of x cube is x to the power 4 by 4. And 4 into 4 will get 16. If I put common, I will get this.
Correct only, sir.
Yes, sir, it's right. Seems right.
Yeah. Okay, I think this is not
Both options is wrong, sir.
both the options are wrong. Yeah, okay. So this one is will be correct. So now let us find out for this particular integral. X squared 2x. Now here, which one to consider first function?
X squared u 2 to the power x equal to v. X squared first function, 2 to the power x second function.
Yeah, because 2 to the power x is the second function, right?
Yes.
Okay. So how to do that? So this will be first function x square integral of 2 to the power x.
2x upon log 2.
Upon log base e.
2x upon log 2, right?
Yes, sir.
Minus integral of 2x into integral of 2x dx. So here I will get x square 2x upon log 2. Here I will get 2x to the power x upon log 2, right?
Yes, sir.
Yeah. So that is dx. So I will simplify this, x square into 2 to the power x upon log 2 minus which one is constant? Log 2 is constant here. 2 log 2 is constant, right?
Yes, sir.
2 log 2 is constant. Integral of x into 2 to the power x, right? dx. Now again, we have to apply integration by part here, right?
Okay.
So I will only solve this integral here now. That is integral of x into the power x dx, right?
Yes.
So again, same thing. First function is x, and the integral of 2x by log x by log 2 minus integral of derivative of this first function, that is 1. Integral of this 2x, that is 2x upon log x by log 2.
Log 2.
Yeah. So if I solve this, x 2x upon log 2 minus integral of again 2x upon log 2 ka square. And everyone got it how log 2 ka square come? Integration of 2x will be again 2x upon log x, log 2, right?
Yes,
This
yes.
log 2 into log 2.
Yes,
log
sir.
2.
Here we take the 1 upon log 2 is a constant term, no, sir?
1 upon log 2 is constant term. Yeah.
Yes, yes.
So x square into 2 to the power x upon log 2 minus 2 log 2 in bracket x 2 to the power x log 2 minus 2 to the power x log 2 ka square. So which one is correct? This one, this one. This one is correct. No, this one is right, right? No, no, this one. So simply we have to multiply this inside the bracket, right? So this is this term, right?
Yes, sir.
So what is second term here? 2x into 2x upon log 2 ka square, na?
Yes, sir. Yes.
So what is 2 into 2 to the power 1, right?
Yes.
So I can
Isn't
write
it the
as x
third
plus
part
1,
is right?
Yeah. Again, same thing. We can multiply log 2 here, the log cube become, right? It become log 2. And minus will become plus. Right? So this one is the correct one. Any doubt in this question?
No,
I have,
No,
I have
sir.
to apply this integration by parts 2 times, right? Yeah.
Yes, sir.
So this one is the final question. Okay. So now which one to consider first and which one to consider second question? Or the second
Sin
term.
x will be the first function, and ex will be the e to the power x will be the second function.
This one is first, this one is second, right? According to ILATE.
Trigonometric and then exponential.
Now let's see. Okay. So what will the first function? We have to keep it first function as it is. Integrate the second function, that is e to the power x only, minus integral of derivative of this first function, that is cos x, into integral of e to the power x, that is second function. Okay. Now again, I have to evaluate this integral, right? So sin x e to the power x minus. Again, I have to apply the integration by parts, right? So
Yes, sir.
So which one is first function, second function?
Same. Cos x is the first function, e to the power x is the second function.
Yes, sir.
Okay, this one is second function. This one is first function.
No, sir. First. Sir.
No, sir. Cos x is first function.
Okay.
E to the power x is second
Now
function.
you can take any one. Okay. So now what I will do, cos x into integral of second function, right? That is e to the power x only, minus integral of derivative of cos x, right? That is minus sin x, into integral of the second function, that is e to the power x.
Yes.
Right. So what I'm getting here, minus e to the power x cos x, minus will come this side, plus sin x e to the power x. See, we are getting the same integral again. If we keep doing, we'll get the getting the same integral again and again, right? If we again apply integration by parts here, we'll get the same thing again, right? Hello.
Yeah.
Yeah, it's just like loop kind of.
Yeah, yeah. Every time we'll get the same thing again. So what we have to
Yes.
do in this case?
So you can assume the first integral to be, for example, I, and then substitute I in the equation you have got just now, and then you can solve
Yes,
for it.
yes, right, yeah. So I can consider this as integral equals to I, right? Let's say. Now this e to the power x sin x minus e to the power x cos x minus. Now this integral I can write it as I, right? And this side also integral is there, that I is there, right? Because actually this is integrating only. Now we are finding out the integration of this function only, that is I. Now this minus I will come on this side.
Should
It
be
will
plus
become,
I?
sorry?
Should it be plus I or minus I?
No, minus inside the bracket or multiplying.
Yeah.
Na? So
Yeah.
minus and this a minus sign, right? So minus this will become this side, so twice of I. So twice of I to the power x sin x minus e to the power x cos x, right? So now my integral will be e to the power x sin x minus e to the power x cos x upon 2. So this is the value of this particular integral.
Okay, we have to understand when we get the same thing, we just have to put the value of I like this.
Yeah, value of I.
Okay.
Okay, any doubt in this problem?
No, sir.
Okay, so just one homework question for you. Just e to the power
Complicated.
a sin of bx dx. Try to evaluate this, okay? Here a and b are 1, right? So here we will get the general formula for this type of integral. Just find out the value of this particular integral. You can search on the internet. Is given in the answer will be given in the internet only. Okay. So what will be the answer here? Like here it will be a into this sin of bx minus e.
Same thing will be here. E to the power x will be the
cos of
continue.
bx, and here a square plus b square, right? So this is the integral of this. Now just put a equals to 1 and b equals to 1 here. So what I am getting here, okay. So here e to the power ax will be there. 90. So here I am getting sin x minus cos x upon 1 plus 1, that is 2, right? E to the power x. If I put a equals to 1 here and b equals to 1 here, right? I am getting the same thing. So general represent equation, this integral of e to the power ax sin bx dx equals to this. Okay. Any doubt? You can try to prove. You can try your own.
So formula is a sin bx.
Sorry.
And that it's written here a sin bx minus
bx.
b cos a.
B cos of ax. No,
Okay.
B cos of bx only.
Bx.
Yeah,
okay,
bx.
okay. Okay.
B cos of bx only. Yes. Okay. Any doubt in any activity question? I think this is the last question.
Yes, sir. Activity doubt is not solved, sir.
Which one? Which activity question?
Wait, sir.
Sir, activity 4, question number 4, sir. Some graphs are given and we have to find the negative area. Whether any
just look at those graphs, na. You can see, na.
Yeah, directly by seeing only we will be identifying, no, or whether any other procedure is available, or just by seeing that negative axis, which all graphs are there, that will be the answer, right?
Yeah, that will be answer. Otherwise, the function will be given to you, f of x, because f of x is not given to you, right?
Yes, yes.
If f of x is given, you can simply integrate between the interval, and if the area comes negative, then you can see, right?
Okay, okay, fine.
Yeah.
Okay, thank you.
Okay.
So where can we find this PDF? Solve with us.
I have taken the question from solve with us assignment only.
But
assignment, not PDF. Okay, wait, I will share my screen. This one, solve with us, not with assignment. All the question I have discussed today.
Okay.
Yeah. So last one was the extra question. I just want to explain that. Yeah. Any doubt in any activity question?
Activity 5, sir. Question number 10.
5.
10. Sir, 9, sir. Sorry.
Question
9.
9.
Yes, sir. How to solve the infinity form, sir?
Just simply integrate na, e to the power minus x. Or integration of e to the power minus x minus e to the power, right?
Yes, sir.
What is the integration of e to the power minus x? What is the integration of e to the power x?
The e to the power minus x plus 1 upon minus x plus 1.
No, no.
I think
It's minus 1 by ex.
Is it visible? My screen visible?
Yes, yes.
So what is the integral of e to the power ax dx? Tell me.
E to the power ax by
E to the power ax by a.
Yeah, to the power ax by.
Yes, sir.
You can try substituting also, you get the same thing, right?
Yes, sir.
So now what is the integral of this? Integral 1 to infinity e to the power minus x. E to the power
Minus
minus
1
x
by
upon minus 1, right?
yes.
So 1 to infinity. Now just put e to the power minus infinity minus minus of plus upon e to the power minus 1. Now e to the power minus infinity will be 1 upon e to the power infinity, right? That will be 0. Yeah. So e to the minus 1 will be 1 by e. So 1 by will be the answer, right? Yeah. Okay. Any other doubt?
Yes, sir. एक minute. The activities are 6, question number 10, sir.
9.6, last question.
Yes, sir.
Okay. So graph is given to you, right? Speed upon time. So distance is basically what?
Distance equal to speed into time. Yes. The distance.
Yeah. So I can write the integral of s dt, small interval dt, right? So it will be the area under this curve only, distance will be, right?
Yes.
So what we have to find out, distance in meters traveled by now in the first 40 seconds.
40 seconds. Sir.
So first 30 seconds, you can directly find out the area under this curve, right? So half of 30 into 120, right?
Yes,
Area of
yes.
this rectangle, so it will be around 1800, right?
Okay, sir.
Now travel for first 40 seconds. Now next 10 seconds here, right?
It's
So
make
for
a
next
triangle.
10, yeah, rectangle
Rectangle.
10 into 120, 1200.
Yes,
1800 plus 200, 3000 will be the answer.
Okay. So 7th question.
Yeah. Okay, which question?
7th, sir. 7th.
7th.
Yes. Sir.
This one. Okay.
Yes. Sir.
Yeah. So what is the integration of this floor function x?
We not get the integration of the greater integers.
What is the integration of this floor function?
15.
Hello? Yes?
Yes, sir.
Yes, anyone? Because you
No,
have to
sir,
find out
don't
the
know how to do the integration of float function or ceiling function. Don't know.
Okay, so integral of this ceiling function, sorry, this floor function dx will be equals to x ceiling value. A hint is given to you in this question.
No, sir.
Okay, so you can note down this integral x into the floor function x minus.
So you are writing, it's not visible.
Okay. Now?
Yes, sir. Yes. Sir.
Yes, sir, visible now.
I will write it again. Okay. So the integral of this floor function dx is equals to x into lower function of x minus lower function of x plus 1 into lower function of x divided by 2. Okay, this is the integral. Like for this 0 to 4, you can simply draw the graph and find out the area. But for this type of question, it will be difficult, right? So for that, you can.
So we have to remember the formula, right?
Yes. So okay, so f1 of x. So integral of f1 of x will be integral of lower function plus integral of 1, right? Hello?
Yes, sir. Yes, sir.
Yeah.
Yes,
So
sir.
integral of lower function will be like this only. X, lower function x minus x plus 1, lower function of x divided by 2, then plus x, right?
Yes.
And this is 0 to 4. Now put 4 here. 4 into what is floor?
4 into 4,
floor
sir.
of what?
16.
16, right?
Yes.
Minus floor 4
5 into
plus 1,
4,
5.
20.
So 5 into
20
4,
upon 4 equal to 10.
20, right?
Yes, sir.
So this one minus, sorry, plus x, that is 4, right?
Yes.
Plus x is
Yes,
also
sir.
there. Integration of 1 is also there, now.
Yes, sir. Yes.
For if you put 0, it will be 0 only, right? So
Yes.
what I will get? 16 minus 10 plus 4, it will be 20. 20?
10, sir.
Or 10, yeah. So this one is the correct one.
Okay.
F2
I-
integration is also same, sir?
Yeah.
So this is all given in the video. I think I missed that. I didn't notice that video.
Which video?
I don't
I don't know reason. That's what I'm
I
saying.
think not. I think not given.
Yeah, I
can-
saw videos, but I don't know. I
You
missed
can
it.
note down this. You can note
Yes, sir.
down
Yes,
this.
sir. Yes, sir.
Okay, so next function is about the ceiling function. So if I know the integration of this floor function, can I get the integration of ceiling function from this only? Anyone?
No, sir.
Why
Class
not?
will be
What is the relation between the ceiling function and floor function?
Whether it is x plus 1 term will be changing to x minus 1, whether that is the only change.
Yeah. See, so ceiling value of 2.4 will be
3.
Huh?
Ceiling value, sir. You are saying
Oh, sorry, floor
ceiling
value
value
will be 2, right?
2. Ceiling
Yes.
value will be 3.
Ceiling value will be
3.
3. So can I
Three.
write it like this? Ceiling value of x will be floor value of x plus 1.
Yes.
Yeah. So can I integrate on both the side?
Yes, sir.
Yes.
Yeah. So this integral I already have here, right?
Yes.
Yes, sir. Yes, sir.
So I am writing in a proper way. So I can write this as ceiling of x equals to floor of x plus 1, right?
Yes,
If I want to find out the integral, I can integrate on both the side. So value of this is already given to me, right? Integral of 1 will be x. So simply I can add x here. So x minus x plus 1 is floor of x by 2. This is the integration of this particular thing and plus x, right? So this will be the integration of this particular function. Now here x equals to, okay, wait. So, okay, so we have done, okay, so if I want to do the integration of f2 of x, so I can write the integration of this plus integration of 2 dx, right? Dx, right? Hello,
So can you explain this thing once?
which one?
F2x is equal to integration of
No, we have to find out this, right? Integral of f2 dx.
yes.
So f2x integral of will be integration of this, right? So I can split the integral, like integral of this dx plus integral of 2 dx, right?
2
I can
dx.
write it like this, right?
Yes.
Now, value of this particular integral is given to me, right? Like,
Yes.
so just put, okay, so here, just put what we have to put 4 here, right? It will be 0 to 4, right? So just put x equals to 4 here. What I will get? Okay, wait, I will write one more step. So this is also 0 to 4, right?
Yes.
So integration of
Yes,
this
sir.
is this. So x, lower value of x minus lower value x plus 1, lower value of x divided by 2, right? Plus x and plus integration of 2x, right?
Yes.
So now we have to put the limit, that is integral 0 to 4. Now I am write it here. So what is 4 into 4? That is 16, right?
16.
16. 5 into 4, that is 20, right?
Yes,
20 by 2,
Yes,
10.
sir. 10.
10. Plus 2, sorry, plus 4.
4.
Right?
Plus 8.
Plus 8. And 0 will be 0, right?
0 will be 0. Yes, sir.
So
18
calculate.
Just we have to add 8 to that
18
previous
answer.
one.
18, yeah. Yes, yes. So this will be the answer, right?
Yes, sir.
Yeah. Okay, same thing. Okay, this one we have checked. This is not equal. For 0 to 100, what we have to do? Just instead of 4, just put 100. Are you getting it?
Okay. Yes.
So instead of just 2,
Big
just put
calculate.
100. What I will get? I will get this only, any value. Either this or this. This will include I get, right? 100 ka square minus 100 ka square minus 101 into 100 by 2 plus 100 plus 200. So this is 10000. This is 50 into 50, right?
50 into 101.
5050 plus 300. So it will be 4950 plus 300. So it will be 5250.
5250.
Any doubt in any other question, activity? Okay, great.
Done, sir.
Okay, okay, we can end this session now. Okay, thank you everyone.
Thank you, sir.
Thank you so much, sir.
All the best
Thank
for
you,
quiz
sir.
team. Yeah,
Thank you, sir.
thank you. Good night.
Good night, sir.